will see the AC output mode. We have selected AC output mode with the help of this selector switch. Now we have to configure the output terminals also. As per the instructions mentioned on the top panel, we have to short EC2 terminal to EC ground, and now we can take AC output with respect to ground. So we have connected a multimeter across the output terminals, and now we are at 0 position, so 0 OK indication is coming up. Means now the output can be initiated. Now we have put on the high voltage and the meter is reading the output voltage. Okay, it means the output is available. So as the multimeter cannot take more voltage, we will stop here. We have just confirmed that the voltage output is available on the terminals. Okay, now we will see the tripping arrangement in the instrument. For that, we have to set this leakage current meter to a desired current level. Let us see, it is set at 8.3 milliampere AC. Alright, now we have to short the output current to output terminal to ground, this link. Okay, now in this case the trip arrangement is like this. The set point is at 8.3 milliampere. If the output current flowing through this link to ground, means the object, if it is failure in insulation, the same condition is created over here. Now if the current flowing through cross the set value, then the output will be tripped off. Let's see. I will put on the means the current is far more than the set point. Let's set more current like this. Press this push button and turn this potentiometer. Let's see if suppose we set the current at say any random value 33.7 milliamps. Now again we will put on. Now here you can see the last tripping was there, so the trip indication has come up, and now we have to reset it. And again we can take the test. See, now the current flowing through this link is 26 milliamps and the set point is at 33.7 milliamps. If we raise it like this, then immediately it will trip because it is crossing 33.7 milliamps. This is all about the tripping. Again we need to reset. This means the trip circuit in the HV test set is healthy. Now we will see the timer setting. This is a timer. Now we can set the test duration, the desired test duration on the digital timer like that. If we want to set this timer for 10 seconds, then first this unit digit we have to scroll to 0. Again this we have to scroll for the second digit 1. Now it is 10. Then set button and then reset button. Now our timer is configured at 10 seconds of test duration. Second thing, the kV measurement and its setting. If we want to take the output say 3 kV approx, we have to set this kV meter approximately 2.7 to 2.8 kV, so that there is a gap of 0.3 kV as a threshold gap. So now we have set it at 2.7, 2.8, so the output will come up approximately 3 or 3.1 kV, and 10 seconds is our test duration. Okay, in this case now our 0, we are not at 0, so we have to press lower push button and come to 0. Now the motor is coming back to 0. Once it reaches 0, the 0 OK lamp will come up, the indication will come up. Till then we have to keep pressed. Now we are at 0, and then only now we can put on the high voltage. Now let's put on the high voltage and press a raise key. It's a one touch key for raising. Now you can see on the meter the voltage is getting raised. Once the voltage reaches the set value, it automatically starts or initiates the timer like this. You can see the timer is running. It has got a pulse from the KV controller and the timer has started for the set value. Once the time is over, the timer trips off the output and the output from the terminal is put off. This means the test is completed successfully without overcurrent tripping. Okay. Now we will see the DC mode. Here we have configured the shorting for DC, like short AC output to DC1 and AC2 to DC2, and get output between DC output and DC ground. And we have to select mode to DC. Okay, now the instrument is configured for DC, but you can see over here we are not at 0 position, so we have to press lower button and bring the output controller to 0. Once we will come to 0, then only we can put on the high voltage. We can check like this. We are not at 0, so we can't put on the high voltage output. So bring the output controller to 0 by operating lower push button. Now we are at 0, so we can definitely put on the DC output. I will just put on the high voltage, DC high voltage on, and a multimeter is connected across the output terminals, so that we can definitely confirm the presence of high voltage output on the terminal like this. You can see over here the high voltage 171 volts. By just putting on the high voltage we are getting, so we confirm that the high voltage output is available on the terminal. Let's put off the output. Again we have to come to 0. We are at 0. Now we have shorted the output terminals to each other, means the output DC output is shorted to the ground. This is a condition like the object across the output terminals connected is fell. In that case, the output current will flow from high voltage terminal towards ground. The same condition will check. Now, as we have set earlier at 33.7 milliampere, the high voltage at say 2.7, 2.8 kV, and the time at 10 seconds. Now as the output is shorted, once I will put on the high voltage, you will see a DC short circuit current will be flowing through and the meter will read it like this. Our setting is at 33.7, but the current presently is 20.5 milliamps. So let us raise little. Immediately it has gone off. Means the current was more than 33.7 milliamperes and the instrument has tripped. A trip indication is come up. We have to now reset. So this is the confirmation that the DC output is available and our trip circuit is healthy. Again the operational. Wow, our setting is at 2.7, 2.8 kV. Milliampere setting is at 33.6 milliamperes and time is 10 seconds. So again I will put on the high voltage and I will press raise so that the output will start. Now the kV meter has crossed the setting, so it has initiated the timer, and when the time finishes